Hey everyone, welcome back to the channel. Today, we're diving deep into a topic that's absolutely critical for every mariner: the limitations and errors in position verification. Even with the most advanced technology on our bridge, understanding where things can go wrong is key to safe navigation. So, let's get started. You've got your position plotted. Everything looks good on the screen, but is it really? The truth is, there are numerous potential sources of error that can mislead you if you're not vigilant. These aren't just textbook theories, they are real-world challenges that can have serious consequences. Let's break down the most common culprits, one by one. First up, and this is a big one, is an incorrect chart datum. We live in a WGS 84 world, especially with GPS and ECDIS, but many older paper charts and even some local electronic charts are based on different local datums. The discrepancy between WGS 84 and, say, a local datum like an AD 27 can be significant, sometimes hundreds of meters. Imagine thinking you have a 200-meter clearance from a hazard, when in reality, you're right on top of it, all because of a data mismatch. It's a silent but dangerous error. Always, and I mean always, verify the datum of your charts and ensure your GPS is set to match. On ECDIS, this is usually managed automatically, but it's your responsibility to be aware of how your system handles different datums, especially when using raster charts. Next, let's talk about our trusty magnetic compass. It's a vital backup, but it's not perfect. Compass deviation, the error caused by the ship's own magnetic field, is a constant factor we must account for. Your ship's steel hull, engines, and electrical equipment all create a unique magnetic signature that deflects the compass needle. This deviation changes with your ship's heading. That's why we have deviation cards. Are they up to date? Have they been checked recently? Relying on a compass bearing without applying the correct deviation is a fundamental error. It might seem small, a degree or two, but over a distance of several miles, that small error can place you significantly off your intended track, closer to danger than you realize. Now, let's move to the radar, our eyes in the dark and fog. While incredibly powerful, radar has its own set of limitations. One of the most common issues is shadow sectors. Large structures on your own vessel, like funnels or masts, can block the radar beam, creating blind spots in certain directions. You need to know where these shadow sectors are on your vessel. You could have a ship approaching from a blind spot and not see it until it is too late. Then there are false echoes. These can be caused by multiple reflections, where the radar beam bounces between your ship and another object, creating a ghost target that isn't really there. Or you might get indirect echoes, where the beam bounces off a large flat surface on your own ship before hitting a target, making the target appear in the wrong direction. Experienced watchkeepers learn to recognize these, but they can easily fool an untrained eye. Don't forget the atmosphere itself. Atmospheric conditions can wreak havoc on both visual and radar observations. On a hot day, you might see a mirage over the water, making distant objects appear distorted or in the wrong place. Heavy rain, snow, or dense fog can absorb radar energy, a phenomenon known as attenuation. This can cause you to lose targets at a distance or see them much later than you would in clear weather. There's also something called anomalous propagation, or anaprop, where unusual temperature layers in the atmosphere can bend radar beams, causing you to see targets from way over the horizon or, conversely, completely miss targets that should be there. You can control the weather, but you must understand how it affects your equipment. And of course, we have to talk about the human element. Human error remains one of the single biggest factors in maritime incidents. Taking a visual bearing, did you line up the Polaris perfectly? When you took a radar range, did you place the cursor exactly on the leading edge of the target? A small slip, a moment of distraction, reading the wrong number, these things happen, especially under fatigue or pressure. That's why one person taking a single bearing is never enough. The process of position fixing should be a deliberate, careful procedure. Rushing it is a recipe for error. Now, let's bring this into the modern ECDIS environment. The ECDIS is a fantastic tool, but it also introduces new types of risk, particularly with how we interpret its information. ECDIS uses layers. You have your base chart. Then you can overlay radar, ice targets, safety contours, and other information. The risk here is misinterpretation. For example, you might see an ice target on the screen and assume its position is perfectly accurate and that it represents the whole ship. But the GPS antenna could be at one end of a 300-meter vessel, and the position might have its own inaccuracies. Or you might rely solely on the radar overlay without cross-referencing the raw radar data on the standalone display. An overlay can be misaligned, or the processing might filter out important, weaker targets. Believing everything you see on the screen without a critical mindset is a trap. The phrase garbage in, garbage out is especially true for ECDIS. If the input data is wrong, the beautifully displayed picture will also be wrong. So, with all these potential pitfalls, how do we stay safe? How do we mitigate these risks? The answer is simple in concept, but requires discipline in practice. Always cross-reference multiple, independent sources and ensure the entire bridge team is in agreement. This is the cornerstone of good seamanship. Don't just rely on your GPS. Take a visual bearing to a lighthouse. Cross it with a radar range to a prominent headland. Check your depth sounder against the charted depth. Does it all make sense? If your GPS puts you in 50 meters of water, but your echo sounder is reading 20, something is wrong. Stop and figure it out. Use every tool at your disposal. This is what we call establishing a zone of confidence. When your position from GPS, from radar fixing, and from visual bearings all plot within a small area on the chart, you can be confident in your position. If one of them is an outlier, you know you have an error somewhere that needs to be investigated immediately. This isn't a one-person job. It's a team sport. The officer of the watch, the helmsman, the lookout, everyone on the bridge has a role to play. Encourage open communication. If the lookout sees something that doesn't look right, they need to feel comfortable speaking up. The bridge team should discuss the vessel's position and the developing situation. Do we all agree that our position is here and our planned track is clear? This simple question can prevent so many errors. It creates a culture of shared responsibility and mutual oversight. A good bridge team challenges and verifies information, not just blindly accepts it. So, to wrap it all up, never trust a single source of information for your vessel's position. Be aware of the inherent limitations of every piece of equipment you use, from the datum of your chart to the deviation of your compass, and the atmospheric effects on your radar. And most importantly, foster a culture of cross-checking and teamwork on the bridge. That's what separates good seamanship from just operating equipment. It's this vigilant, questioning mindset that will keep you, your crew, and your vessel safe. Thanks for watching, everyone. I hope this was a helpful breakdown of a really important topic. If you found this video useful, please give it a thumbs up, and don't forget to subscribe for more content on navigation and seamanship. Drop a comment below with any questions or your own experiences with position fixing errors. Stay safe out there, and I'll see you in the next video.